In section 11.2 in our Math for Elementary School Educators, we are looking at prime factorization, and I want to look at a factor ladder. Okay, there are two ways to do prime factorization. One is using a factor ladder, one's using a factor tree. Okay, a couple things before we start. Number one is that you should kind of know your prime numbers, at least the first couple prime numbers. And we did that in the Sieve of Eratosthenes. I still cannot say that. So just to remind you of some prime numbers that you want to start off with, 2, 3, 5, 7, 11, 13, 17. So here are just a few of the prime numbers that we're starting off with. So what I'm hoping to do is, given any number, I want to write it as a product of primes. That's what a prime factorization is. Prime factorization is taking any number and writing it as a product of only primes. Okay. Cool. So what I'm going to do is I'm going to show you the factor ladder method. So let's say that I want to do the prime factorization of the number 18. Okay, so I want to be able to write 18 as just a bunch of prime numbers multiplied together. Okay, so what I want to do is I want to take that number 18 and I'm going to do what's called a factor ladder, and you're going to basically do upside down division. Okay, and what you're going to do is you're going to take the first prime number, which is the number 2, and you're going to say, hey, does 2 divide 18? Well, yeah, 2 divides 18. I get the answer of 9. All right, awesome. Now, we're going to repeat this. Does 2 divide 9? No, it doesn't. So what we're going to do now is we're going to move to the next prime number. So we already used 2. It doesn't work anymore, so now I'm going to use 3. Does 3 divide 9? Yes. 3 divides 9, and I get 3. Can I divide 3 by 3 again? Yeah. 3 divides 3, I get 1. You know you're done with this process when I get 1 on the outside. When the very, very, very last number is the number 1. All right, now, my answer is 2 times 3 times 3. So the prime factorization of 18 is 2 times 3 times 3, or using exponents, it would be the same thing as 2 times 3 squared. Okay, so both of these work. All right, let's try another one so that way you can see, obviously, some variation. So let's say that I had the number, 48. Okay, so if I want to find the prime factorization of 48, I would want to go to my very first prime number, which is 2, and I'm going to divide by 2 until I can't anymore. So 2 goes into 48 24 times. Boom. I can divide by 2 again. 2 goes into 24 12 times. I can divide by 2 again. 2 goes into 12 6 times. I can divide again. 2 goes into 6 3 times. I can't divide by 2 anymore. So I'm going to look at my list, and I have the number 3. Does 3 go into 3? Yes, it does. Okay, so I keep going until I get a 1. My answer is all the answers on the outside. So 1, 2, 3, 4 2s, and a 3. So 48 is the same thing as 4 2s and a 3. That is the prime factorization of 48. Okay, hope that helps with the factor ladder. I'm going to go ahead and do one more example in a separate video, which is a bigger number.